So here we have our question of the week. You can see the question. A function is given which involves some trigonometry sine in series form, and there is some limit, and the question asks to evaluate or find the value of f of pi by 3 and f of pi by 6. You can pause the video and try to solve it on your own. It's not that lengthy. If you get the one step, then it becomes easy, and like 5 or 6 steps the question will be solved. So I hope you have tried to solve this. So here I have already solved the question. I will just explain you through the steps. So the first step is I have written this whole series in sigma form, you can see. And one way to solve such sigma is to create a telescopic series where we create two things in difference, and like fn plus 1, fn minus fn type, or fn minus fn plus 1 type. So this is known as telescopic series format, and when we open the sigma, the terms will get cancelled out, only the first term and last term remains. So how we have transformed this expression into this? So first and the most important step is to write this sine to the power 4. This is argument or the angle inside sine. So I have splitted sine to the power 4 in sine square 2 to the power rx and sine square 2 to the power r into x. Yeah, and we can write, we know sine square theta is 1 minus cos square theta, so I've written it like this. Then multiply this sine square with 1, we will get this, and multiply sine square with this, we will get this sine square into cos square. And now if you know a little bit trigonometry, then sine theta into cos theta is 2 times sine theta into cos theta is sine 2 theta. So here if we add 4, so I multiplied with 4 and divided by 4. Now we are getting, it is like 2 sine 2 to the power rx into cos to the power x whole square. So we can write this as sine 2 times. So it becomes sine 2 times 2 to the power rx, same as sine 2 theta formula we have used. And if we apply here property of exponent, so it becomes r plus 1. So sine square 2 to the power r plus 1x, and here also 4 to the power r plus 1 it becomes. So you can now see that this expression has become a telescopic series format or difference of two terms. So let's call this tr and this tr plus 1. So if we put it, if we open the sigma, then we will be only left with t0 and tn plus 1. You can remember this result directly. So what will be t0? We will put only r is equal to 0 here. So it becomes 2 to the power 0, 1, and it becomes 1. So we are left with sine square x. And here if we put n, tn plus 1 means here we have to put n. So sine square 2n plus 1 by 4n plus 1. Now we also have the limit. So here there is no n. So it remains as it is, sine square x. Here we know that the range of sine square of anything is between 0 to 1, and in the denominator it is tending to infinity. 4 to the power infinity will tend to infinity, obviously. So what can be the value of this expression? In numerator there is a number between 0 to 1, and in denominator there is a infinity, so it will tend to 0. So the value of this limit is simply sine square x. So we got our function, a very good function, sine square x itself. Now it's easy to evaluate. Sine square pi by 3 plus sine square pi by 6. You can write sine square pi by 6 as cos square pi by 3 by complementary angle. Pi by 2 minus pi by 6 is pi by 3 itself. So this is nothing but sine square pi by 3 cos square pi by 3. We know sine square theta plus cos square theta is equal to 1. Or we can put the value like sine pi by 3 is root 3 by 2. So it becomes 3 by 4 plus 1 by 2, 1 by 4. It is also 1. So that's it. The important step is only this. How to create this expression in telescopic series format so that we are left with this simple expression and the limit is easy to evaluate. So always remember, in such type of question, somehow create this difference such that the terms will get cancelled out and we get a simple result. Yeah, that's it for the solution. I hope you understood the explanation and like the question. That's it for today. Thanks for watching.